All right, let's jump right in. For decades, we thought about black holes as these singularities, right? These points of infinite density where all the laws of physics just completely break down. But what if that whole picture is just wrong? Today, we're diving into a really radical new idea that completely reimagines what black holes are. What if a black hole isn't an object at all, but a phenomenon of projection? So that leads us to the big question for this explainer. What if that event horizon, that point of no return, isn't where reality itself ends? What if it's just a point where our ability to see that reality collapses? A place where the universe's projection screen just goes dark? You see, in this model, space-time isn't some smooth, continuous sheet. It's actually a hidden lattice made of tiny geometric units. A black hole, then, is just an area where this lattice is squeezed into an extreme state of compression. And the event horizon? Well, think of it like this. Imagine you're watching a movie, but the projector is aimed right into your eye. The film is still running, the information is all still there, but the projection is so intense that all you see is blinding white light, or in this case, a perfect black. The structure underneath is fine, we just can't see its shadow anymore. Now, to really wrap our heads around this, we have to look at the fundamental building block of space-time in this model. Let's see how it constructs a totally new picture of our reality. It all boils down to this little thing, the Ur cell. The best way to think of it is as the fundamental pixel of reality. It's a dual-tetrahedral shape, basically a tetrahedron and its inverse, stuck together. And the whole idea here is that all of space-time, the entire universe, is built from these tiny elastic geometric units. But here's where it gets really cool. The Ur cell isn't just a static speck. It's more like a tiny, multifaceted crystal. It can vibrate, it can twist, it can compress, all in these hidden internal ways called modes. So a vibration in one direction, the W2 mode, is what we experience as electricity. A little twist, the W3 mode, that's magnetism. And when it gets squeezed or expands, the W4 mode, well, that's what we feel as gravity. And this is the absolute key to the entire framework. We never get to see these internal workings directly. The vibrations, the twists, the compressions, nope. Instead, everything we experience as reality, including the flow of time itself, is just a projection. It's like a shadow cast by all these hidden internal dynamics onto one single observable axis, which they call W1. Okay, so with that foundation laid, how does this framework explain something as huge and fundamental as gravity and time? This is where the model really starts to shine. You know, in Einstein's theory, gravity is this abstract concept of warped space-time. In this model, it's much more, well, physical. Gravity is simply the actual squeezing of this lattice of Earth cells. It's like squeezing a sponge. The more mass you have, the more the cells in that area get compressed. And this isn't just some vague concept, it's backed by math. The model actually produces the standard, well-tested formula for gravity that we use all the time. What this equation is really telling us is that the amount of squeeze on the lattice is directly related to the mass of an object and how far you are from it. It takes that abstract idea of a gravitational field and turns it into a direct, physical compression of space itself. So let's just put these ideas side by side for a second. In the standard view, we think of time as being fundamental, and gravity is what warps it. But in this new MMU view, the lattice is what's fundamental. Gravity compresses that lattice, and that compression changes the projection of the lattice's internal state. We then observe that changing projection as what we call time dilation. It's a total flip of cause and effect. Okay, so now we can finally bring it all back to the black hole and see how this new way of thinking completely redefines its most famous and infamous feature, the event horizon. So the event horizon gets a new definition. It's simply the exact spot where the lattice is compressed so extremely that the observable projection, that shadow cast on the W1 axis, just vanishes. It literally goes to zero. Reality doesn't end there. Our window into it just slams shut. The internal structure of the Earth cells keeps on doing its thing on the inside. We just can't get any information projected out to us anymore. And this single idea of projection collapse has some truly profound consequences. First, it perfectly predicts the size of the event horizon, that famous Schwarzschild radius. Second, it gives us a whole new origin for Hawking radiation, suggesting the temperature comes from the sharp edge of this projection. And third, the totally baffling concept of black hole entropy suddenly becomes beautifully simple. And what's really incredible is that this reinterpretation doesn't just feel neat, it actually works. This framework derives the exact accepted formula for Hawking temperature, so the math is identical to the standard model, but the origin story is completely different. The temperature isn't from some mysterious quantum fluctuations in a vacuum, it's a direct result of the geometry of the projection itself as it collapses to nothing. So, what about that tricky thing called entropy? Well, instead of being some mysterious thermodynamic property, this model says it's just counting. That's it. The entropy of a black hole is literally just the number of fundamental Ur cells you would need to tile its entire surface area. It's a simple, geometric counting of the microscopic bits that make up the horizon. All right, let's pull all these threads together now and look at the brand new unified picture of black holes that this framework is painting for us. So here's the big takeaway. Every single key aspect of a black hole gets a new, direct geometric weaning. Gravity isn't a warp, it's a physical deformation of the spacetime lattice. Time isn't fundamental, it's a projection from that lattice. The event horizon isn't an end, it's where that projection collapses. Hawking temperature is the gradient of that collapse, and entropy is just counting the cells on the surface. And this is so important to get. This model isn't trying to throw out the successful formulas of modern physics. What it aims to do is give them a new, unified foundation. The math we use stays the same, but the interpretation, the meaning behind it, shifts from abstract fields and warped spacetime to a concrete underlying reality that is geometric and projection-based. And that leaves us with a final, pretty wild thought. If black holes can be reframed in this way, what else can? Could things like dark matter or dark energy, or even the weird measurement problem in quantum mechanics, could they also be mysteries not of some new substance, but of projection? Problems that arise simply from our limited view of a much deeper geometric reality.